Hey guys, I'm going to show you a couple of pointers on how to solve equations. I'll start simple and get a little bit more complicated on the way. So let's start simple. So the whole goal is to find a variable and figure out what makes it true with an equation. So say we have 2x equals 4. Well, we're going to say, well, what times 2 equals 4? In this case, 2 times 2 equals 4. So we know the answer. So let's go ahead and show this. So in Algebra 1, you have like different properties of equality, but for now, we're going to isolate this variable by getting it by itself by undoing the operation done to it. Well, this says 2 times x. So how do I undo 2 times x? The opposite of multiplication happens to be division. So 2 divided by 2, or two equal groups of something equals 4. So 4 divided by 2 would say that this becomes 1 and goes away. So x is now equal to 2. So 1x gets 2 values, whereas 2x's get 4 values. So if this is true, we plug this back into our equation, and so we would say, well, 2 times 2, because x is 2, this is x, equals 4. If that is true, then our solution is correct. So 2 times 2 does equal 4, so we would say check. That's good. Okay, so into a more complicated equation, this would be what you would call a one-step equation. Other types of one-step equations look like this, where we have, let's say, x over 2 equals 4, and we'll say, well, what divided by 2 equals 4? Well, to get rid of this, to undo division, we have to multiply. So to get rid of this 1/2, or I could rewrite this to say 1/2 x is equal to 4. I can say, well, to get rid of the 1/2, I multiply everything by 2, or 2 over 1. But whatever I do to one side, I have to do to the other. So 2 over 1 over here, this becomes 2 over 2, and 2 over 2 becomes 1. It's gone. Now 4 times 2 over 1 becomes 8 over 1. So x is equal to 8 over 1. Okay, so it seems complicated, but we have to get rid of this fraction by making it become one whole. Because the whole goal is to figure out if half of x gets 4, what does one whole x get? And one whole x gets 8. So if that's true, let's find out. 8 over 2, I'm replacing x with 8. Does that equal 4? Well, 8 divided by 2 does equal 4, so this is a true solution. Okay, now I've shown you two simple one-step equations, and I will box these up so you can identify that these are two different equations. And remember, the difference between an equation and an expression is obviously the equal sign, right? So let's go into a two-step equation. So a two-step equation would be one where you have 2x plus 4, and I'm using nice clean numbers that work, but even if these numbers didn't work, if you follow this process, you should be fine. So first thing we need to do is on a two-step equation, and we're using order of operations, is to undo addition or subtraction. Because remember, our goal is to have our variable on one side and our number or constant on the other. Okay, so variable is good. There's only one variable, so we can put a check there. We have that done. So now how do I get the constant to the other side? Well, if this is plus, to move it to the other side, to balance this out, I have to do the opposite to make it go away. So minus 4. That makes a 0 pair, so that's 0. But remember, what I do to one side, I have to do to the other. So use subtraction property of equality, or just subtract 4, right? So that leaves me with 10 minus 4 is 6. So my number is all on one side, so I'm going to check that out, and I'm going to bring down whatever I have left. In this case, 2x equals 6. Okay, so the last step, this now becomes a one-step equation. So what times x, or 2 times what makes this true to become 6? So I divide both sides by 2. Okay, and we know this becomes 1, it goes away. 6 divided by 2 becomes 3, so 1x equals 3. If this is true, we check our work. We say that 2 times 3 plus 4 equals 10. So to make this true, we're going to do our math. 2 times 3 is 6. 6 plus 4 equals 10. 6 plus 4 does equal 10. So check. Our solution is good. Okay, so that's a two-step equation. It doesn't get too much different than that other than if we're paying attention to negative signs. So say, for example, we had, and this is another two-step, and we can do some equations with variables on both sides and distributive property if need be. But let's go ahead and look at, let's say we have, I don't know, 3x minus, or let's do plus 15, and that's going to be equal to negative 35, or negative 30. Let's do negative 30. I think that works out pretty good. So same thing, draw my line so I know that I'm working equally on both sides. What I do to one side, I do to the other, and it just keeps things nice and neat so I can balance my equations nice. To get rid of this 15, well, first, where I start, I want my variable on one side and my number on the other, my constant on the other. So I'm going to subtract 15 to make this become 0 because I need it to go away from this side. But what I do to one side, I have to do to the other. So minus 15 here. And a negative minus a negative, this like addition. So this becomes negative 45. And that's equal to 3x. Okay, so 3 times what would make this true? To find out, we would do the opposite of multiplication and do division. So 3 divided by 3 becomes 1, and negative 45 divided by 3, x equals negative 15. Is it okay for x to be negative in this case? Yes. Our variable itself cannot be negative, but our solution to be true can. So let's double check to make it true. So we would say 3 times negative 15 plus 15, does that equal negative 30? Well, 3 times negative 15 is negative 45. Okay, negative 45 plus 15 does equal negative 30. So it ends up working out nice and neat. Okay, so we would put a check there and a check on our solution. And so in a nutshell, the steps are as follows when we're doing two steps equations. First, we're going to undo our operation to get our constant to the opposite side. So it's either addition or subtraction to move our constant. And then once we've done that, and I'll check that off. Once we've done that, we undo the operation to get rid of the coefficient in front of the variable. And I'll go into more of that in the next video. But once we've done that, we isolate our variable, and once we've isolated it, got it by itself, we can see if it's true by putting that solution back into the original equation. And if both sides are equal, then we have done it correctly. Okay, so this was my first video on equations. Be on the lookout for some more. I'll show you the parts of the equation, including dealing with distributive property as well, and variables, equations with variables on both sides. So hopefully this was helpful. Be on the lookout for more content. Thank you.